In the previous video, we found out that we can in fact have isomers, which were, remember, the same molecular formula but a different structural formula between compounds. We can have isomers existing within one homologous series. And in that video we looked at C4H10, which was an alkane, but we found that we could draw it in a couple of different ways. We could give it a couple of different structures. So now what we want to do is come up with a better way to name these structures so that we can tell the difference between them, because now butane is not detailed enough, because this is butane, but this is also butane because it follows all of these rules. So if you've not watched that previous video, watch that one before continuing on with this video. So to answer that question, to be able to name these molecules, these structures a bit more detailed, in a more detailed way, we're going to look at something called systematic naming. And this is extremely important in chemistry, all right through up past National 5. And what this enables us to do is to use the structure itself to give the compounds a more accurate name, rather than just simply butane. And that will enable us to tell the difference between different molecules, different isomers, different structures based on their structure. So what I'm going to do, I'm going to show you this structure here, and we're going to take our time and go through the systematic naming process in detail to come up with a detailed name for this compound here. So if we look at it, we can see that it's slightly different from the compounds that we've looked at so far. Now it is in fact an alkane, which we'll prove in a little second, but looking at it, what can we see already? Well, we can see that it's a saturated compound, it's a saturated hydrocarbon. How do I know that? Well, it's saturated because it only contains single bonds, and it's a hydrocarbon because it only contains hydrogen and carbon. So we know that right off the bat. Now, what we can also see is that it's not a perfectly uniform straight chain. There's a little kind of extra carbon thing going on up to the top left here. And that is what's going to present us with some issues, because we can't just give this a simple name like we did before, like butane or pentane or hexane, just based on the number of carbons alone. We have to detail where those carbons are and what other carbons they are bonded to. That is what's really important here. And there's a few rules that we use to do that. So, first of all, we have to identify the longest chain of carbon atoms that are all bonded in one line, one continuous chain. And to do that, I'm going to start using a couple of different colours so that this is really clear. All we're going to do is look for that. We're going to look for the longest chain of carbon atoms. So I'm going to start from the left. I'm going to suggest that we go right through to the right. So we have 1, 2, 3, 4, 5 carbons. So 5 could be our longest chain here. Now, we could also start from this carbon here, because this one is joined onto this one. And then we have two choices. We could either go left or right. So if we go 1, 2, 3, well, that's not very long at all. That's certainly not as long as 5, so that's not the longest chain. But we could go 1, 2, 3, 4, 5, because those carbons are all joined in a line too. So we're left with the choice between 5 this way or 5 this way. And the answer is, both answers are actually acceptable. But for just now, we're just going to stick with what looks the easiest. Okay, which is the easiest to look at, and that is to just identify the straight chain in the middle or at the bottom as the longest chain. So I'm going to draw a blue box around that just now, just to show that that is our longest chain, and we have 5 carbons in it. So that's the first step. Second step would be to number these carbons, and we want to start at the most exciting end. So by exciting end, all I mean is the side that actually has something interesting going on, whether it be one of these branch things or some kind of functional group, which we'll look at in later videos, but the side that has the most going on. So clearly in this case, if we choose between the left side and the right side, it's the left side that's the most exciting, because we've got this kind of branch thing going on here. So we're going to number them starting at the left. Now please note, it will not always go left to right. In this case it does, because the left happens to be the most exciting end. But always look out for that. It might be the right, it might be the bottom, it might be the top, Who knows? Just always look for the most exciting end, decide with the branches or the functional groups. So going with that, we're going to say that this is carbon 1, this is carbon 2, and so on. 3, 4, and 5. Okay, so that's that done. So now we know we have 5 carbons in the longest chain. This is already going to help us because we know how to name an alkane with 5 carbons in it. We already know how to do that. So that's going to come in handy in a second. The final step then is to name and number any branches that we find on the structure. So let's have a look. We have our nice straight chain of carbons going across the middle, but then we've got this guy up here. We've got a carbon atom with 3 hydrogens joined onto it. There is a name for what that is. That is a branch, and it's a branch because it branches off of the main chain. Now branches themselves have to be smaller than the main chain because of course we've looked for the longest chain at the start, so anything coming off of it should be shorter than the main chain itself. And at National 5 level there are 2 branches that you have to remember, you have to be able to identify and name. So first off is the one that we have right here. Single carbon with 3 hydrogens coming off of it. And the second is a chain with 2 carbons with 5 hydrogens coming off of those. And I'll just draw a little squiggly line just now to represent that these are joined onto the rest of the main chain. And these have names of their own. If we see a branch that looks like this, it has a C with 3 hydrogens on it, we call that a methyl group. And if we have a branch with 2 carbons and 5 hydrogens coming off of it, we call that an ethyl group. And these shouldn't be too difficult to remember because they match the prefixes that we already know for naming alkanes and alkenes and cycloalkanes. We've got the meth or meth part for 1 carbon, same as methane, and we have the eth or eth part for 2 carbons, like ethane or ethene. So what we want to do is use that knowledge of what these branches are called to name and number the branch that we have in our compound. So by name, I just mean choose one of these names to match however many carbons are on the branch. And by number, I just mean indicate which carbon of the main chain it is bonded onto. So if we have a look at our structure, this branch, which happens to be a methyl branch, is bonded to carbon 2 of the main chain. So it's 2-methyl is the name of our branch. So now we have all the information that we need to actually name this systematically. So the way that we do it is we just go through the rules. And one by one, we make sure we include all of the information to show what our structure is all about. So in our main chain, we have 1, 2, 3, 4, 5 carbons. Because we have 5 carbons, we know that this structure is some kind of pentane. Because it has 5 carbons in the main chain, we use a pent. And it ends in ane because it is an alkane, because it's all saturated single bonds. And it follows the alkane general formula of CnH2n plus 2. Now I know what some of you are thinking, well, how can it be pentane? We've got an extra carbon here. Does that not make it hexane because there's 6 carbons altogether? Well, yes and no, because that extra carbon acts as a branch. So we name it and number it like a branch. It's on carbon 2, so we're going to call this 2 something, and then we're going to use a dash, and we're going to name what type of branch it is. In this case, it is a methyl branch. So our full systematic name for this compound is going to be 2-methyl pentane, because we have 5 carbons in the longest chain, and we have a methyl group on carbon 2. And you'll notice that when I'm separating numbers and words in systematic naming, I use a dash, and that just keeps things nice and neat. So that gives us a starting example of how to systematically name a hydrocarbon compound. What we're going to do in the next video is look at a few more examples that are a little bit more complex so that we can see this process in a bit more detail.